Good day, everyone. I am Jessica Edna May Siciliaros, and this is the continuation of our topic, utilization of assessment data. So for today, I will going to discuss what is Z-score and T-score. So the Z-score and T-score are used for the hypothesis testing. The Z-score gives the number of standard deviations of a test score above or below the mean. The formula is Z equals where is X is the test score, X is the average score, and S is the standard deviation. A negative Z-score means it is below the average, while a positive Z-score value means it is above the average. In a 50-item math test where the mean is 25, and the standard deviation is 10, a score of 35 has a Z-score of 1, which means that it is a standard deviation above the mean. A Z-score of 1 translates to a percentile rank of 84, which means that the student score is about 84% of the score. So Z-score, the formula of Z-score is score minus mean. Mean is the average or the totality divided by the standard deviation. So a Z-score is from the data of population. In order to be able to use a Z-score, you must know the standard deviation of a population, and the sample size should be above 30. If you can't meet both of those requirements, use the T-score instead. So what is Z-score? Technically, Z-score are conversion of individual scores into a standard form. These conversions allows you to more easily compare different parts of data. This distribution is based on your knowledge about the population's standard deviation of mean. So, the result of Z-score will tell you how many standard deviation for mean your result is. So, the example is, if you get the Z-score of 1, that tells you you are 1 standard deviation from the mean. We can also use a normal distributions to find what percent of the population will fall below or above your result. So the next is the T-score. In a T-score scale, the mean is set to 50 instead of 0, and the standard deviation is 10. To transform a Z-score to a T-score, we multiply the Z-score by 10 and add 50. So T is to 10, Z plus 50. A Z-score of negative 1.5 converts to T-score of 35. A T-score of 35 indicates that the raw score of 12 is 1.5 standard deviations below the mean. This implies that based on the test scores, the student performed below the average. So unlike Z-score that is from the data of population, T-score is from the data of sample. And the sample is only part of the population. So the formula of this T-score is T equals to open parentheses of Z-score times 10 close parentheses plus 50. So T-score is from the data of samples, remember that? And the general rule of T-score is the sample size must be below 30 and it has a unknown standard deviation. T-score is also a conversion of individual scores into a standard form. That's all.
A STA9 or standard 9 score is a method of rating on a 9-point scale. It may be used to reduce any test score to a single digit. STA9 star Z-score and T-score are a means to assign a number to a member of a group relative to all other members of that group. While Z and T scores can be stated as decimals such as 1.2 or 3.25, STA9s are also positive whole values ranging from 0 to 9. STA9s resemble normal distributions as well. Consider these scores to a bell curve that has been cut into 9 sections. These are numbered 1 through 9, beginning with the left-hand part. However, where the mean of a normal distribution is 1, stan nines have a mean of 5 and a standard deviation of 2. So what is exactly are stan nines? As a score of 9 places a person in the top of 4% of scorers, while a score of 1 places them in the worst 4%. These sorts of scores make it simple to determine if a score is below a score of 5 or above the mean. A stanine of 1, 2, or 3 is considered below average. 4, 5, or 6 is considered ordinary or average. 7, 8, or 9 is rated above average. So the STAN9 score indicates a child's overall level of achievement below average, average, or above average. So, how to get the standard 9 or STAN9? So this is the formula of STAN9, which is 2z plus 5. So z means the z score. So for example, the given z-score is negative 1.5, 1.5, and 2.5. Calculate STAN9 scores for the above z-score. So, as we know, SS or standard score is equals to 2z plus 5. So, if our z-score is negative 1.5, then our standard score is 2 times negative 1.5 plus 5. First, you will multiply the 2 times negative 1.5. Then, it results a negative 3. Then, you finally add the 5. So, our standard score is 2, and that means it is below average.
Thank you so much for that very wonderful explanation about Stanine, Miss Jezreel. Good day, everyone. My name is John Marquez Mabingnay, and I'll be the one who is going to report about normal curve equivalent, or also known as NCE. So the normal curve equivalent is a normalized standard score within the range from 1 to 99. It has a mean of 50 and a standard deviation of 21. So it was first developed in RMC Corporation in 1975 to measure the effectiveness of the title program across the USA, and is often used to measure gain over score. So this model, it is more focused on the progress of the student um, throughout the semester or throughout the quarter. And yeah, caution should be exercised when converting a raw score to NCE because the latter requires a representative national sample. So, meaning you should always base on the technical manual for the particular assessment that you are using. So, NCE is preferred by some because of its equal interval quality. Score differences between tests among subtests in a test battery can be calculated and examined. What I mean by that is, if you will notice, normal curve equivalent is, as you can see, it's almost similar to percentile equivalent. The difference is, kung nakikita nyo, yung interval nitong normal curve equivalent is consistent, 1, 10, 20, 30, 40. Unlike in percentile equivalent, it's kind of arbitrary. And then here is the formula on how to get the NCE or the normal curve equivalent. So, very direct and simple lang. Bale, standard deviation multiply to z-score plus 50. So, in the previous synchronous session, na-report na ng ka-groupmate ko na si Mr. Billones kung paano kuhain yung z-score. So, after mo makuha yung z-score, I know alam niyo na yung process. Gagamitin nyo lang tong formula na to. So, ayun, 21.6, which is the standard deviation. Imagine na kinukuha yung z-score is 2.2. I-multiply nyo yun, wait, i-multiply natin. 21.06 times 2.2 equals 46.33 plus 50. So the NCE is 96.33. And pag minark nyo siya, nandito siya, somewhere dito, sa red dot na yan. So that is the normal curve equivalent. Now let's move on to developmental scores. So developmental score is also known as GE or grade equivalent. Describes learners' developmental growth. It gives a picture to where he or she is on an achievement continuum. So, ayun. Itong developmental score, ginagamit to para malaman yung progress ng isang student sa learning niya sa loob ng ilang months, kung ilang months na ba tumatakbo yung semester. A grade equivalent is an estimate of a learner's location in development continuum and not grade level from where she should be placed. Kasi dito sa grade equivalent, ang ginagamit na terminologies is grade 1, grade 2, grade 3, grade 4, grade 5, and so on. Pero, ang ibig sabihin ng term na yon is not the grade level, but the rating of yung rating ng learning ng estudyante. So yun, one criticism against GE is that it assumes that equal learning occurs throughout the year, which is far from truth. Further, it cannot be used to compare a student's performance in different. So, ayan. Para mas maintindihan nyo siya, here is the example table. So, ayan, mag-focus kayo sa side na to, kung saan ko tinuturo yung mouse. So, sa concepts of number, subject yan. So, ito yung mga scores ng mga estudyante. So, yan. So, dito sa student na to, napunta siya sa percentile rank na pang 53. And nakakuha siya ng STA9 na 5. And ang grade equivalent nun is 8.1. So, yung kaklase niya naman na mas nasa baba is napunta sa percentile rank na 50. And ang STA9 is 5. Nakakuha siya ng grade equivalent na 7.8. So, by the way, mga grade 7 students to. So, yung mga mas average na estudyante, nakakuha sila ng 7.8, 7.5, 7.2, etc. Tapos, itong pinakaunang student, medyo above average sa iba, nakakuha siya ng 8.1. Ibig sabihin ba nun, may knowledge na siya na pang grade 8, pang 8th grade? Hindi ganon. Ibig sabihin lang na mas angat yung progress niya kaysa sa iba. And then, kung paano naman kinukuha yung grade equivalent, sa pagkakaalam ko, iba-iba siya, depende sa technical manual ng particular assessment na ginagamit. nyo. Ayun. And that's the end of my report. Let me give the screen time to Miss Aspie.
Norm reference interpretation. Scores show how a person compares or compared to the initial planning population. People's scores are compared to those of other people. Relative standing is used for interpretation with little focus is placed on the exact amount of instrument must possess the necessary expertise to make variations between people. The main benefits of non-reference assessment is that they too can show how a person's test performance stacks up against that of other in the sample population. The fact that the study population might not accurately reflect the actual population of interest is a key drawback of norm reference tests. Norm reference tests typically make use of a nationwide peer group. Comparing a student's performance to that other students in a chosen peer group is the main objective of these examinations. Students do a test. The results can there be analyzed by teachers to discover more about the performance of their students. Examples: the 72 nation percentile indicates that a student's test results are at or above the performance level of 72% of students nationwide, which is higher than the national for that student's grade and testing period. Next is citation reference interpretations. A test score is interpreted using criteria in order to determine the knowledge, capabilities, and talents that a person or group can display in a relation to a properly specified content or behavioral area. It is frequently defined as standing in opposed to norm reference interpretation, in which a score only has significance when it is compared to scores of other people. Interpretations that are used on criteria are separate from data that is centered upon what the average person does. This item expands on standards interpretation and its applications before discussing the construction and development of tests that support it. Citation reference translated scores have been utilized for a number of judgments, including assessing the effective of educational initiatives and issuing license. Examples: both the established objectives of achievement tests and advanced placement exams are standardized tests that are given to students across the country. Difference of NRI and CRI. Inferences regarding test takers' performance on a particular assessment can be drawn into two different ways, using norm reference and criterion reference testing. These different building techniques overlap acting objectives, and scoring. Interpretation techniques distinguish these two testing kinds. Criterion reference tests assess an examination taker's performance in relation to a particular series of standards and criteria, whereas norm reference examinations compare test takers to the other person. That's all.